Right, we'll come back to our next chapter. Right, the new chapter is deal with the probability. The probability. What probability does is it's measure the likelihood of occurrence of a particular event. What we will learn how to interpret probability values The probability is always expressed between the values 0 and 1, included. Unusual. Well, if we have probability smaller than 5%, then we say, well, that's simply very unlikely or unusual to be happened, right? That's unusual. Probability smaller than 5%. So that is basically what we will see in our chapter here. Right, a couple concepts. Procedure. Like the action you do, right? Such thing like to flip a coin, to roll a die, or roll two dice, right? The dice or die is singleton, or the dice is plural, right? Dice, yes, it's plural. That is just six-sided usually, right? Maybe usually six-sided, 1, 2, 3, 4, 5, 6. Or pick up cards. Or so, right? Some events like that. Or you flip a coin, you roll a die, or pick up cards, are pretty much random enough. A procedure simply action where the outcomes, in other words, is results, are random. Well, when you flip a coin, you are not sure what it will come out is a head or is a tail. When you roll a die, it could be either 1, 2, 3, 4, 5, or 6. When you pick up one card, you could get one card from 52. Right, regardless the jokers, right? When you pick up cards, that is 52 cards. Well, if you don't know what the outcome looks like, I will upload the outcomes, or you can search them online if you want to. The play cards or the dice, maybe not everyone knows how they look like. Right, so it means the results from you pick up cards or roll dice or flip coins, they are random. Those kind of thing is the procedure, right, to do that event. To do that action. Any collection of outcomes of a procedure is called event. Or for instance, right, to roll 2 dice, the event could be the sum of the 2 dice facing value is greater than or equal to 8. To pick up cards, like to pick up 2 cards, the event could be to pick up both of the cards are red, or both of the cards are face cards, which means jack, queen, or king, right? That could be the events, the collection of any outcomes. When you flip coins, maybe like you flip 3 coins, the event could be at least 2 heads, right? That could be an event. When you flip 1 coin once, the event could be it lands on the head. When rolling 1 die just once, the event could be you get faced on an even number, right? That could be just any possible outcomes of that action. The collection of that is called the event. And sample space is a set of all possible outcomes is the set of all possible outcomes, and especially of a probability experiment. So when you do the procedure, right, like you flip the coin once, then the sample space will be either the hand that it lands on head or lands on tail. When you roll a die, it could be either 1, 2, 3, 4, 5, or 6 as the sample space of you roll a die once. Right? If you pick up a card, that will be 52 different outcomes. If you pick up 1 card, right, that will be 52 different outcomes in the sample space. To roll a die once, the sample space will be that. Right? The thing I post will be the sample space of the rolling 1 die, rolling 2 dice, or a deck of cards, how it looks like. I pick up once. That will be the other things. An equally likely event is the event that has same probability occur. Like if you flip a coin, right, the head will tell you if the coin is fair, right, then to get a head or to get a tail is an equally likely event. If the card is well shuffled, then to get any one card out of 52 is equally likely. And if you roll a die once, to get, if the die is a fair die, well balanced die of course, then it to get either side 1, 2, 3, 4, 5, 6 is equally likely. Right? That is equally likely event. And usually what the notation is we use letter to represent for events. Can be have any letters such as A, B, or C, or so, whichever. You just define them or will be given. Right, then the probability of E is the probability of event E occurs. That is the probability of event E occurs. Right, so that's basic concept. We will see more, like in the example it will be more clear, but the procedure, right, the event, sample space will be all the collection outcomes and equally likely event. E is the event and the probability of E, that will be the probability of the event E occurs. And maybe for some other letters it's all appropriate using the other way. And then we have three approach. The relative frequency approach, three different approaches to find the probability basically. Well, the first one, relative frequency approach, is in other words is to find out the relative frequency, which basically is the number of E occurs over the total. Such thing like if you don't know a coin is faired or biased or how it's biased, we could just try to flip the coin. Right, that the condition will be very, very tricky in that case. Well, we need to make sure that every time we have same force and so on, same position or so. Right, but that will be large number. Not hard enough, and we need to find out large number. Maybe to flip the coin 1,000 times is still considered as not that large. Maybe 10,000 times or 50,000 times of flipping the coin and counting, well, if we interested in if the coin, how biased it is, right? So we can count the number of head being occurred in each time. Maybe for 50,000 times, that has 20,000 times, about 20,000 times, it is a head. And then we can, from that, we're able to get the probability. But this is time consuming. Of course, we are doing a theoretical course, not that much theoretical, but a basic course here, and nothing should be that complicated to deal with the real experiment like 50,000 times. It may take maybe a couple months to do that, right? So it will be tricky, and just for one procedure we take that much time. It's also not usually useful. So the second is classical approach. And what we usually use is the classical approach to find the probability in our course here. If the classical approach is that, well, if a procedure has n simple events that occurs equally likely, and there are s different ways that the event E can occur, which means like if you rolling one die, right, there are, if the die is fair, of course, there are 6 different outcomes, and each one is equally likely. To find out the event that the die coming out facing value is even, that will be 3 different ways to occur. Right, the probability is S over N. Right, the probability is S over N. That's the usual approach we use. Right, so for example, right, the die is fair. To find the probability, getting an even number. Right, so to flip a die once, we get the sample space is 1, 2, 3, 4, 5, or 6. Right, that's in our sample space. And the die to be even, that's 2 or 4 or 6. Right, so the probability of the event E, if we denote the event as E to be even landing, we get 3 even numbers, possibly, out of total outcome to be 6. Right, rolling one die, that's 6 possible simple events, that is 6 only possible outcomes can be occurred and since the die is fair, they are equally likely. Right, then there are 3 different ways to make the face value to be even. That we get is 3/6 is the probability, and if you want to simplify as 1/2. Right. You could simplify it, you could divide it, you could make it into decimal, or you could make it into percent. But usually always personally, right, I do is the fraction will be good enough. If you want to divide into decimals, that's also fine. Right, but always I need to see the middle steps, right, how to build this probability. Right, that's the classical approach, which is we usually use, and we use a lot in our course here. Right, that's classical approach. And the last one is subjective probability. The subjective is just simply, literally just subjective. The probability is found based on knowledge relevant circumstances. Right, based on the knowledge. For instance, like, well, maybe today is very humid and it's raining, right, basically. It's humid and raining. And you can see towards the evening or towards the night that the cloud is still very strong. Right, not clear yet. Right, that it will be very likely that maybe tomorrow is still raining. Right, possibly, or if you see the cloud is very heavy, and today is such like not raining that huge, right, not raining that heavy. Then maybe tomorrow it was still raining. But if you see that well today is raining very heavily, and the humidity kind of drops off, then maybe tomorrow will be not raining. Right? That will be from the observation of your knowledge. From the observation of from your knowledge, you're finding the likelihood of raining tomorrow or no. Right? That is kind of the subjective. It's very subjective. And the law of large number the law of large numbers say, well, you use relative frequency approach to find the probability. Then if you repeat the procedure again and again, which the relative frequency approach say large number of procedure you're doing, but you're doing that really large amount of time. Right, then the relative frequency approach tends to approach the actual probability. Well, it will tend to approach to the actual probability. Since we're doing a relative frequency approach, that is the law of large number, which is just for information. Right? We do the best way is to, in real life, right, is to do the experiment over and over, that we get the relatively better idea of what the object will be, or what the probability will be for a special event. Right, so let's see some example how to find the probability about the drug screening test. The results. Uses drugs. Positive test result. Right, for drug screening tests, for the positive test results, that's 44 and 90, which means 44 subjects uses drugs and gets the positive test result. And 90 of the subjects is not using drugs but also gets the positive test results. 6 of them have the negative results from and also uses drug. 860 not use drugs and gets the negative test result. Right, so to find that's the given table, right? To do the question, we need to find the total, right? The total of the column. The column has two things, right? But this column is about the positive test result, that he has 134 objects or subjects are positive test result. 866 of them has negative results. Subject uses drugs, that's 50 of them, and 950 of the subjects are not uses drugs. And the overall total will be the same column total or the same row total, that is 1000. So you find the sum or find the total of the table, of the two-way table. We need to be careful that the column total and the row total at the end should add up to the same number. Right, so what's being asked is that one subject is randomly selected. What is the probability to get a subject has positive test result is not use drug. Right, the classical approach we use, right, the probability of E that is S over N, which N is the total and E and the S here is how many ways that E can occur. Right, so probability, we get a positive test result, a positive test result, that is how many of the positive from the total, right? The total is 1,000. From positive test results, that is 134 of them. Right, so to select one randomly, we get 134 possible selections over 1,000 total. You divide that 0.134. Right, the probability of not using drug, we could use the letter B, say not use drug. Or we could use letter N, say not use drug. Right, stand for. Doesn't matter, we just use the letter. Right, that will be 1,000 in total. And how many of them will not use drug? Right, the row total is 950 of the subjects actually not use drug. That will be 950 over 1,000. That is 0.95. We always use the classical approach to do so. We get 1,000 possible total subjects to be selected, and from the possible positive selection is 134 of them. So select one, that's 134 over 1,000, and the possible selection from the negative, from the subject not use drug, that's 950 of them. So 950 over 1,000 will be the probability of selecting one not use drug. Right, so that is this approach. And let's see the next question. What is the probability of getting two boys and one girl if the couple decide to have 3 kids? Right, 2 boys and 1 girl, that is could be very in different order, right? Depending on what is the first kid, what gender is the second kid, and what gender is the third kid. Right? Of course, the first boy, the second is a boy, the third is a girl. It's different from the first is a girl, the second is a boy, the third is a boy. Right? That is a different choices of different selection, different collection basically, of in different order. Right? So what we can do is to find a tree diagram to list out all the possible outcomes. Right? The first could be a boy or could be the girl. Right? That is definitely correct, right, for the birth, for the order of birth. Right? Then if the first is a boy, the second child could be either boy or girl. Right? If the second is first is girl, the second child could be boy or girl, right? That's also appropriate. Right, then if the first two are boys, the third ones could be still boy or girls. If first is boy, second is girl, it can also be a boy or a girl. And so on, right? Follow the same idea that no matter what the previous kid is boy or girl, that the next could still be the boy or the girl. Right? So from that diagram, we just count in each path, what do we have? Right? We could have all the threes are boys. We could have first two boys, the third is a girl. We could have the first is boy, second is a girl, the third is a boy. Or the first is a boy, the other two are girls. Right? And from the remaining four paths, that's girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. So that gives us the sample space, right? Of 3 children, the sample space are 8 different possible collections. Alright, let's denote the E to be 2 boys, 1 girl from the couple. Right, then the probability of the E, we'll see. Right, it's no doubt that there are 8 possible collections, 8 different outcomes in our sample space. Then to be 2 boys and 1 girl, we have boy, boy, girl, and a boy. And then the first is girl, the second 2 are boys. Right, those 3 are following the condition to be 2 boys and 1 girl. Right, that's 3 of them. So we have this probability to be 3 out of 8. And next, what is the probability Oh, we know that the Thanksgiving Day has to be Thursday. Right? That no matter which year we observe, or from the past or from the to the future, right, the probability of the Thanksgiving follows on the Thursday is always correct. Right? That it's always correct that no matter which day or which year you observe, the Thanksgiving Day is always falls on a Thursday. As different years we observe, that should have always falls on that, which basically that is 1. And the falls on a Monday, that's never, right? Whichever day we observe, that is 0. So in the future that it will be 0, that the Thanksgiving Day falls on a Monday. Right, that we could this have probability of 0 is impossible event. And we call that those probability to be 1 is the certain event. We could consider that the probability of the impossible event is 0 and the probability of the certain event is 1. But always in that case. Right, and especially for any type of probability. Right, the from event to be impossible to certain, that covers every case. So we have the probability of any event should fall in between 0 and 1. Well, we never get the probability to be 0. We never can get probability, to be smaller than 0. We can never get the probability to be more than 1. But 0 or 1 are included as the special case, and everything else should be in between.